Well, grade 12s, in this lesson, we're going to be focusing on one of my most favorite topics in maths called calculus. Okay, calculus dates back to the great mathematicians like Isaac Newton and Gottfried Leibniz. These guys created the most incredible mathematics involving things like rates of change and gradients of all sorts of curves and functions. And we're going to look at this at a very simple level. So I'm going to start off with the concept of what we call a limit. So let's look at limits and develop it. I'm not going to get too technical. At university, you will get very, very technical. But for our purposes, what I want to do is just explore the very basics of what a limit is. You're going to need this as we go into this topic in more detail. Okay, so let's start off by drawing the graph of fx is equal to, I'm going to make up one. It's a parabola, x squared plus 1. Now remember, fx is always y. Now just as a matter of interest, it's not really important for now, is how does this graph look? The graph of y equals x squared plus 1. We know it's a parabola, but let's see what it looks like. Well, if we just quickly basically select some values for x, we'll choose them at random, minus 1, 0, 1. What would x squared be? Okay, if you look at x squared, well, if you square the x's, you get 1, 0, and 1. But what we've actually got to do, we've got to take the x squared graph and add 1, jump it up by 1. So that will be adding 1 to all of these guys here. So 1 plus 1 is 2, 0 plus 1 is 1, and 1 plus 1 is 2. So it's like saying negative 1 squared plus 1 is 2, 0 squared plus 1 is 2, or 1 squared plus 1 is 2. So what it really involves, if you think of just normal graphs, if you take the graph of y equals x squared, this is just for interest at the moment, you've got 0, 0, minus 1, 1, and 2, x is 1 and 1. Look at that. Now that's the basic graph of y equals x squared. And then what did we do? We lifted it up by 1. So this point goes up to there, minus 1, 2, 0, 1, and x is 1, y is 2. So your graph of x squared plus 1 has no x-intercepts, and it cuts the y-axis at 1 and has a turning point at 1, and that's what it looks like. So for our purposes, I've just quickly revised the sketching of that parabola, but what I really want to do is I want you to focus on a concept that we call limit. Okay, now what I'm going to do is, this is the graph of fx is equal to x squared plus 1, the graph of y equals x squared plus 1, the parabola. Now what I want to do is I want to select any x value, and I'm going to explain to you what a limit is by using this diagram. Just a basic understanding of a limit. Now, if I said to you, if x is 1, you've chosen 1. I just made it up. You could choose any x value you like. Now, if x is 1, what would the y value be? Well, we know that fx is x squared plus 1. So how do we get the corresponding y value? We'll replace all the x's with 1. And what do we get? 1 squared plus 1 is 2. So the y value here, which is f of 1, is actually 2 there. That's the y value. Pretty easy to understand. Now what I want you to do is I want you to pick a value to the right of 1. Now let's suppose I chose at random 3. Now I'm going to go up to the graph here. There we go. And I'm going to go across and I'm going to say, let's work out what the corresponding y value is. Well, what would be the f of 3? Okay, we'll be replacing all the x's with 3, so that gives us 9 plus 1 is 10. Now this is not to scale, it's not drawn to scale, but that's the y value. So at 3, the y value is 10. Let's get closer to that chosen value 1. Let's go to 2. X is 2, let's choose that. And let's go up to the graph. And let's see what the corresponding y value is. Well, what is the f of 2? Well, let's look at the f of 2, which is the y value corresponding to x is 2, which is 2 squared plus 1, and that's 5. 2 squared is 4 plus 1 is 5. So your y value here is 5. Now notice, as we select values to the right of 1, and we start moving from right to left and approach 1, the y values will move 10 all the way down 5, and they will approach 2. So as the x's approach 1 from the right side, the y values are coming down and they're approaching 2. Now likewise, if you pick a value to the left of 1, let's say a half. Okay, not to scale this, we'll take a half and naught. Let's see what happens if we go to x is a half. What are the y values doing? Have a look here. Well, what is the f of a half? Well, that would be a half squared plus 1, which is a quarter plus 1, which is 1 1/4. So the corresponding y value here would be 1 1/4. Now if we choose naught, it would be 1, because what is the f of naught? Is naught squared plus 1, which is 1. Now look at this. If the x's come from the left, they start small and they increase. And as we move from left to right, as the x's increase, the y values are going from 1 up to 1 1/4, and they approach 2. Now this is a very complicated concept in the world of maths, but I'm going to show you some very simple notation. What we say is the limit, now watch this, the limit as x approaches 1, now that could be from the left and the right, okay, of the graph, of that graph, the limit as x approaches 1, notice that it's called the limit as x approaches 1 of the graph, is actually 2. We're approaching, as the x's are approaching 1, as we're moving from right towards 1 or from left towards 1, the y values are coming from the top and the bottom. They approach 2 as x approaches 1. It's quite difficult, this, but what we know is that if you look at this, the simplicity, we're saying that the limit as x approaches 1 of the graph is actually the y value. We're approaching a y value of 2 if x is going to 1 in either direction. And look at this. If we say limit, underneath notation wise we say x arrow 1, the graph is actually x squared plus 1. Now if we say what is the limit, what is the y value approached if x is approaching 1, all you do now is you drop the limit symbol and you plug in the 1, we're approaching 1, and the y value we approach is 2. So all you do is you take 1 and you sub it in, and look at that, and you get into the graph, and there you get 2. So what is a limit? It's the y value approached as we approach a given x value. So in an essence, what's happening with this limit thing, if we have a look at, if you've got a parabola graph, look at this, goes like this, and you choose 1, as x approaches 1 in either direction, where the y value is going to, they're approaching from top and bottom, they approach to, the y values are approaching 2. And we say that the limit as x approaches 1 of the graph, x squared plus 1, is approaching a y value of 2 by merely substituting in. Okay, you could have also chosen, if you think about it here, if you choose, for example, let's go choose x is equal to -2, let's make it up. Well, what would be the limit? It would be the corresponding y value. Okay, it would be the corresponding y value, which would be about 5 as well. Okay, now look at this. If you look at this, what is the limit? The limit as x approaches -2 of the graph. Where's the graph going? Simply put, nothing in it. You simply substitute the -2 for x into this expression and you get 5. So this is the y value approached by the graph, okay, on the graph, if the x's are approaching -2. It's very simple, this. And even if you don't really connect with the graphs, don't worry. Just know that you need to substitute that in, and there you go. And you've got the limit is the y value approached as x approaches -2. So that's an important thing. We've got these graphs here, this graph here, and there we go. And as we approach a selected value of 2 or -2, we look for the y value by subbing in. So maybe we should explore a few further examples and show you how actually easy it is to work out a limit. The graph or the graphical interpretation of it is quite a mission, but don't stress too much. It's just leading to an important thing. So have a look at this. If I said to you, let's evaluate the limits as x approaches negative 4 of this parabola here, whatever, it doesn't matter what the graph is. All you do is the x is approaching negative 4, so what is the y value being approached? All you do is you sub in the negative 4, substitute it in like that, and there you get 16 times 2 is 32 plus 4, which is 36. Okay, we can look at another example, B here. What if I said to you, what is the limit, the y value approached, if x approaches 2 of this funny looking little graph here? Now, don't panic with what it looks like. It's just some graph. Now, how do we get that limit, or the y value approached if x approaches 2? Well, let's drop the limit symbol and plug in 2 squared minus 4 over 2 plus 2, which is 4 minus 4 over 4, which is 0 divided by 4. 0 divided by 4 is simply 0. So as x approaches 2, this graph, whatever it is approaching a y value of 0. It's the y value we're approaching if x approaches 2.